Hello ladies and gentlemen, my name is Okta Pratama, NIM 101-19056. Now, allow me to introduce the topic of my final project, that is scheme association in category theory. First, I will explain what is an association scheme. The association scheme is an extension of the group concept. The concept of an association scheme can be constructed from a transitive group on a finite set. This concept is used in various topics, especially in mathematics, such as combinatorial design and coding theory. The n-class association scheme can be expressed as a pair, X a set, and S partitions of X cross X with the members of S being binary relation R0, R1, Rn, so that S is subset of X cross X. Following are the properties of the association scheme. First, identity relation. The second, a kind of exchange relationship. Third, a kind of transitive relation. From the transitive relation type properties just now, we have defined Pijk, which depends on Ijk instead of X and Y. We can define a commutative association scheme that is Pijk equal to Pjik for all Ijk. And then a symmetric association scheme is one in which each Ri is a symmetric relation, that is, if xy in Ri, then yx in Ri, equivalent with R star equal to R. If an association scheme is symmetric, then it's commutative, but not necessarily the other way around. Commutative is not necessarily symmetrical. The association scheme only generalizes to commutative groups. Remark: if xy in Ri, then xy are called its associates. The definition states that if x and y are its associates, then so are y and x. Every pair of points are its associates from exactly one I. Each point is its own zero associate, while distinct points are never zero associates. If x and y are kth associates, then the number of points z, which are both ith associates of x and z associates of y, is a constant Pijk. Terminology and facts: the number Pijk are called parameters of the scheme, are also referred to as the structural constants. P000 equal 1, that is, if xy in R null, then x equal y, and the only z such that xz in R null is z equal x. And the sum of Pii0 equal to the number of set x, because Ri partition x. Let's look at some examples. First, the Jones schemes denoted by J. And then the Hamming scheme denoted by H. The next example is some kind of regular graph. For your information, regular graph is a graph where the degrees for every vertex is the same. A distance regular graph G forms an association scheme by defining two vertices to be ith associates if their distance is I. And also, strongly regular graph is a two-class association scheme. And then a finite group G yields an association scheme on X equal to G with a class Rg for each group element as follows. For each G in G, let Rg equal to xy, where x equal to G star y, where star is the group operation. The class of group identity is R0. This association scheme is commutative in only if G is abelian, and then so on and so forth. Now, let's move on to category theory. Imagine we have an object O that we don't know yet. To be able to know more about this object is to try to hold it, feel it, wave it, or measure it. To better understand the nature of this object, let's see what is the relationship between this object and other objects. For example, we have the object O. We do something like we put this O object on the T scale. We do an action on this object O. This object O acts on the scale T. Or, for instance, we measure object, we apply ruler U to object O. To find out the characteristic of an object, we don't need to dissect its matters. That is the set of atoms denoted by O. Or let's say we want to know the hardness of object O. We can hit object O with hammer P. Or we can throw object O at someone else. If he screams, it can be said object O is hard. Or maybe we throw something that is not hard like a sponge, but he still screams. That means he's overreacting. In general, we assign another object P to object O with the notation P arrow O. Based on set theory, maybe we try to look at the contents of object O. We see the constituent atoms. The problem is, can the atoms that make up O tell us about the nature of object O? Maybe, but we don't want to. Then, I will explain what is the definition of category theory. Category C consists of, first, C object, the objects in category C. Second, C arrow, direction of arrows between objects in C. Objects and arrows fulfill several properties. For each C arrow, he has a target and a source, which is an object in C. Where this arrow doesn't have to be a mapping. And A is source of arrow F and B is target of arrow F. The next properties is transitive properties like C is equipped with partial operation like this. Fg can be operated to get an arrow from A to C named G compose F. For each object A, there is an arrow that we give a name 1A, where 1A is similar to identity transformation. With properties F compose 1A equal to F and 1A compose G equal to G. And the second properties of array operation are associative, like this. Remark: a collection of C object or C arrow does not necessarily form a set. In general, we say that an object is a class. Some classes are a collection of sets, some are not. What does a collection of something not look like? R is X where X not in X. Is R a member of R? If R in R, then R is not in R. If R not in R, then R not in R. Proper class is a class that is not contained in any other class, whereas C or set is not a proper class, that is a class contained in another class. We consider the set as a small class because there is a class whose members are larger than the set. The second remark, in the definition of the category, it is not necessary for every two objects to have an arrow connecting them. The third remark, we write the operation from right to the left because later we will see that in many situations the operation on the arrow is not defined but inherited from the compositional nature of the function. Therefore, we use function composition notation. If we are in a group, we tend to use the A star B operation. However, since the arrow is a function, we prefer to use G compose F. For example, this example is a simple form of the operation property of the arrow with the identity generating itself and the property of operation of the two arrows we can make like a composition function. That's all for me. Thank you.